Hello, my dear students. Welcome back to another session of WAPSI. Yes. Okay. So we can directly move on to the first question. Yes. So the first question is given that if z is equal to x plus iy, then the equation modulus of z plus 1 is equal to modulus of z minus 1 represents which one? They are asking which one. That means y-axis, a circle, that means the second option. Third option is a parabola and the fourth one is x-axis. So first of all we can write, it's given that z is equal to, x plus iy. So this is the question, z is equal to x plus iy. Then the equation modulus of z plus 1. Modulus of z plus 1 is equal to modulus of z minus 1 represent which one they are asking. Okay, so in the first step, it's given that z is equal to x plus iy. So modulus of z. So first of all, we can substitute here. Z here. So modulus of x plus iy plus 1 is equal to modulus of x plus iy minus 1. Okay. So in the next step, we can write it as x plus 1 plus iy, nothing, just rearrange x plus 1 plus iy, that is equal to modulus of x minus 1 plus iy. Okay, so this is modulus. So modulus means we can write this is equal to modulus of x plus 1 plus iy. So that is equal to root of, we can write it as root of x plus 1 the whole square plus y square, that is equal to root of x plus 1 the whole square plus y square Yes. So here it is equal to root of x minus 1 the whole square, x minus 1 the whole square plus x minus 1 the whole square plus y square. Now look at here. In the left hand side and also in the right hand side there is square root. So we can cancel this. So that will be equal to x plus 1 the whole square plus y square is equal to x minus 1 the whole square plus y square. Okay, so we can cancel the square root on both sides. So that is in the next step we can write x plus 1 the whole square plus y square is equal to x minus 1 the whole square plus y square. So hereafter just expand this, expand x plus 1 the whole square. That is in the form of a plus b the whole square. So on expanding this we will get x square plus 2x plus 1 plus y square, that is equal to x square minus 2x plus 1 plus y square. So hereafter, now look at here. So hereafter we can cancel the x square on both sides, cancel x square and y square. Yes, similarly we can cancel y square. Yes. Now look at here, 2x. So just move this 2x to the right hand side. So it will become 4x is equal to, and just move the 1 to the right hand side. Nothing, first of all just move the minus 2x from the right hand side to the left hand side. So the minus 2x, when we are moving minus 2x to here, it will become positive 2x. So 2x plus 2x, that is 4x, and just move the 1 to the right hand side. So 1 minus 1, it is equal to 0. Is 1 minus 1 equal to 0. So that means x is equal to 0 by 4. So x is equal to 0. So which represent which axis? X is equal to 0. That means this represents y-axis. This represents y-axis. Okay. So for this question, option A is the correct answer. So option A means y-axis. So that is the correct answer for this question. Yes. So this one represents modulus of z plus 1 that is equal to modulus of z minus 1 represent the y axis. Now we can move to the second question. So the second question is given that the value of 16C9 plus 16C10 minus 16C6 minus 16C7 is. So we need to find the value of this. So first of all we can write 16C 9 plus 16 C 10 minus 16 C 6 minus 16 C 7. So we need to find the value of this one. Okay? Yes. So we know that NCR is equal to NCR. So we can write NCR is equal to NC N minus R. Okay, so we can write NCR is equal to NC N minus R. Now look at here. So I'm going to change this. That is 16C6 for 16C6. By using this, I'm going to write 16C. What is the value of N? N is equal to 16 minus R. Look at here. N is equal to 16 and R is equal to 6. So 16 minus 6, the value is 10. And here, for this one, 16C7. Again, for 16C7, I'm going to write it as that is equal to 16C. Yes. 16 minus 7. So the value will be equal to 9. 16 minus 7, the value will be equal to 9. Okay, so 60 minus 7, the value will be equal to 9. So in the next step, we can write this as, that means instead of 16C6, I'm going to substitute it as 16C10, and instead of 16C7, I'm going to substitute it as 16C6. Okay, yes. So in the next step, we can write it as 16C9 plus, no change in the first two terms, 16C10 minus 16C6. The value means 16C10 minus 16C9. Okay, because we already find the value of these two in the previous step. So 16C10 minus 16C9. Now look at here, 16C9. This is plus and this is minus, cancel. Yes, so this will cancel. So what is the value? That is equal to 0. That means the value is equal to 0. Now look at the options. So while we are going through the options, we can see that the first one is 17C2 and the second one is 0 and the third one is 1 and the fourth one is 17C10. Okay, so for this question, we can see that option B is the correct answer. That means the value is equal to 0. So option B is the correct answer for this question. So we can move on to the third question. So the third question is given that if the parabola x square is equal to 4ay passes through the points 2, 1, then the length of latus rectum. So we know that the length of latus rectum that is equal to 4a. So first of all, we can write the given hints. The parabola, if the parabola x square is equal to 4ay. So this is the parabola x square is equal to 4ay passes through the point. So the point is already given, that is equal to 2, 1. So 2, 1 is the points. Yes, 2, 1 is the points. So the length of the latus rectum, we need to find the length of latus rectum. Yes. Latus rectum. So the length of the latus rectum. Now look at here, x square is equal to 4ay. So the length of the latus rectum, we know the length of the latus rectum that is equal to 4a. Length of the latus rectum that is equal to 4a. Okay, and also here, look at here, x square is equal to 4a. So from this we can find the value of a. So how we can find the value of a? Just substitute this 2 and 1 here. So x square. So on substituting x is equal to 2, we will get the left hand side is equal to 4. 4 is equal to 4a into 1. 4a into 1. So hereafter we can write 4 is equal to 4a. Therefore, a is equal to 4 divided by 4. So the value is equal to 1. So the value of a is equal to 1. So similarly, we can write 4a. Because we got the value of a is equal to 1. So we can write 4. The length of lattice rectangle 4a, that is 4 into 1. The answer is 4. Okay. So the length of lattice rectangle, that is equal to 4. So for this question, look at the options. Okay, so while we are going through the options, we can see that option C is the correct answer for this question. Option C is the correct answer. That means the length of lattice rectangle, that is equal to 4. Okay, now we can move to another question. Yes, look at the question. It's given that if the sum of n terms of an AP is given by Sn is equal to n square plus n, then the common difference of the AP is, okay, it's given the sum of n terms of an AP is given by Sn, sum of n terms, Sn is given by, Sn is equal to n square plus n square plus n. So this is Sn. Then the common difference. So we need to find the common difference for this question. We need to find the common difference for this one. Yes. It's already mentioned this is an AP. Yes. Sum of n terms of an AP is given by Sn is equal to n square plus n. So we need to find the common difference of this AP. Okay. So Sn is equal to n square plus n. So hereafter, first of all, I am going to write the sum of first terms. So S1 is equal to. So instead of n, I am going to substitute it as 1. So yes, S1 is equal to 1 square plus 1. So the answer is 2. And this is for the term 1, first term, T1. And S2. So that means 2 square. Yes, 2 square plus 2. 2 square plus 2, that means 6. So for this one, we can write as T1 plus T2. T1 plus T2. So hereafter, we can write, therefore, T2 is equal to S2 minus S1. T2 is equal to S2 minus S1. S2 minus S1. That means 6 minus 4. That is equal to, 6 minus 2. 6 minus 2. The answer is 4. So 6 minus 2, that is equal to 4. That is equal to 4. So the common difference, so that we can write the common difference, or another way we can write the common difference, D is equal to second term T2 minus T1. T2 minus T1. So that is equal to 4 minus 2. 4 minus 2. So the value is 2. Is it clear? So the common difference is 2 here. Sn is already given this question. So from this we can write S1 is equal to, instead of the value of n, just substitute 1. So S1 is equal to 1 square plus 1. So that is equal to 2. So that is equal to T1. And S2. So S2 is equal to 2 square plus 2. That means that is equal to 6. So we can write as T1 plus T2. So from this we can write T2 is equal to sum of S2, sum of second terms. So S2 minus S1. S2 minus S1. So that is equal to 6 minus 2. So we will get S2 minus S1. The value is 4. Yes. So that means T2 is equal to 4. T2, second term T2 is equal to 4. So hereafter we can find the common difference D. Yes, the common difference D is equal to T2 minus T1. 4 minus 2. So the value is 2. Now look at the options. So while we are going through the options, we can see that yes. So for this question, option D is the correct answer. That means 2 is the common difference for this question. Yes. Okay. So the next question is given that the standard deviation of the data. So the data is given 6, 7, 8, 9, 10 is the standard deviation. So we can write as SD. The standard deviation of the data 6, 7, 8, 9, 10. Okay, so the standard deviation of the data 6, 7, 8, 9, 10 is. We need to find the standard deviation of this one. So first of all, from this one, from the given, we can find the mean. Okay, so the mean x bar, mean is represented by x bar, so that is equal to, just add this, 6 plus 7 plus 8 plus 9 plus 10 divided by the number of terms. How many terms are there? Yes, 5 terms are there, divided by 5. So that is equal to 40 divided by 40 divided by 5. So we will get 8. We will get 8. Yes. So the mean x bar, so we can write x bar, mean x bar, that is equal to 8. Mean x bar, that is equal to 8. So from this we can write we can find the standard deviation. So what is standard deviation? Standard deviation is represented by sigma. The standard deviation, the standard deviation is represented by using this symbol, standard deviation. Yes, so this is a symbol for standard deviation. Standard deviation. Yes. So standard deviation is equal to, therefore the standard deviation, that will be equal to, this is the formula, root of 1 by n. N means the number of terms. Yes, sigma. Sorry, the sum of xi minus x bar the whole square, xi minus x bar the whole square. So here x bar is the mean. Okay, so what is the value of xi? Let me write the xi once again. So xi is equal to, yes, so xi 6, 7, 8, 9, 10. So these are the xi. So sum of xi minus x bar. We know that the value of x bar is equal to 8. Okay, x bar is equal to 8. So xi minus, first of all we can write xi minus x bar. So 6 minus 8 for the first one, 6 minus 8, so that is equal to 2. So square, 2 square means 4. And the second one, 7 minus 8. 7 minus 8, the value is equal to 1. 7 minus 8, the value is equal to minus 1. So minus 1 the whole square, yes, that is equal to 1. And the next is 8 minus mean. 8 minus mean, 8, that is equal to 0. The square of 0, again 0. And on the next step we can write, yes, 9 minus 8. 9 minus 8, so the value is 1. And on squaring this, we will get the same value, that is equal to 9. And for the next one, 10 minus 8. 10 minus 8 means 2. 2 square means 4. 2 square means 4. Yes. Okay. So in the next step, we can substitute here. Sum of xi minus x bar the whole square. So this is the value of xi minus x bar the whole square. This is the value xi minus x bar the whole square. These are the value. So hereafter just add this. That is 4 plus 1 plus 1 plus 4. Yes. That is equal to, simply we can write, that is 10. That is 10 divided by, what is the number of terms? 1, 2, 3, 4, 5. N is equal to 5. So that means in the next step we can write it as root of 10 by 5. 10 by 5. So let me show here. Yes. So standard deviation, root of standard deviation, root of 1 by n, 1 by 5, 1 by 5 into sum means 4 plus 1 plus 0 plus 1 plus 4, 1 plus 4. Okay, so that is equal to square root of, yes, root of, what is the sum of this? The sum of this is equal to 10 by 5. So yes, standard deviation is equal to root of 10 by 5. We already know that 10 by 5, what is the value? 10 by 5 is equal to 2. Yes, so 10 by 5, the value is equal to 2. So hereafter, in the next step, we can write the standard deviation. SD is equal to, yes, the standard deviation. Standard deviation. SD By using symbol, we can write, yes, this is equal to square root of 2. Square root of 2. Yes. So this is the final answer. That means for this question, the standard deviation of the given data. So the value is, okay, you can see there are 4 options: 10, root 2, root 10. Yes, 10, root 2, root 10 and 2. So for this question, option B is the correct answer. That means square root of 2 is the correct answer. That is, the square root of 2 is the standard deviation of the given data. Okay, so let us move on to the next question, my dears. So the next question is given that if A is equal to 0, 0, 1, 0, 1, 0 and 1, 0, 0, then we need to find the value of A raised to 4. That is, A raised to 4 is equal to, so it's given that A is equal to, if A is equal to 0, yes, 0, 0, 1, 0, 0, 1 and 0, 1, 0 and 1, 0, 0, 1, 0, 0. Then we need to find A raised to 4. So first of all, we can find A square. So what is A square? A square is just multiply this. Multiply A. A square is equal to, we can write A square is A into A. A into A. So on the next step, we can write this one as 0, 0, 1 and 0, 1, 0, 1, 0, 0. Yes, 1, 0, 0 into, again, write the A matrix, 0, 0, 1, 0, 1, 0, 1, 0, 0. Okay, so just multiply this. Just multiply this. So on multiplying this, this is A square. This is A square. This is A square. That means multiplying the matrix A 2 times. So A square means A into A. Okay, so on the next step, we can write this. This is equal to, okay, 0 into 0, A square. Let me write A square. So 0 into 0, so 0 plus 0 plus 0 plus 1. Okay, so that is the first element. And for the second element, 0 plus 0 plus 1 into 0, 0 plus the third one, 0 plus 0 plus 0. Yes, so here again, yes, this row into this column. So 0 plus 1 into 0, 0 plus 1 into 0, 0. And on the next, 0 plus 1 plus 0. And hereafter, this row into the last column. So that means 0 plus 0 plus 0. Okay, and for this one, 0 plus 1 into 0. 1 into 0 is 0. 0 plus 0 plus and 0 into 1. 0 into 1 means 0. 0 into 1 means 0 and 0 plus 1 into 0. Yes, this row into this column. Okay, this row into this column. So 0 plus 0 into 1, that is equal to 0 plus 0 plus 0. The last one is 1 into 1, 1 plus 0 plus 0. Yes, so we got an I matrix. So on multiplying this, we got an I matrix. A square is equal to I. Identity matrix A square. So I'm going to write as I. A square is equal to I. I means which matrix? I is equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. So this is the I matrix. A square is equal to I. So in the question, we need to find A raised to 4. A raised to 4. What is the value of A raised to 4? So I square is equal to, A square is equal to I. We know that A square is equal to I. So A raised to 4, that is, we can write as A square the whole square. Yes, A square. What is A square the whole square? A square the whole square means A raised to 4. Okay, so that is equal to I square, because A square, the value of A square is equal to I. We got A square is equal to I, so I square. So what is the value of I square? The value of I square is I. The value of I square is I. So A raised to 4, the value is equal to I. A raised to 4, the value is equal to I. So simply we can write A raised to 4, the value is equal to I. A raised to 4, the value is equal to I. So, okay, so for this question, option D is the correct answer. Look at the options. Option D is the correct answer for this question. So, now let us move on to a simple question. So, the question is given that if A is equal to elements of the set A is equal to A, B, C, then the number of binary operations on A. So, first of all, let me write A is equal to set, yes, capital A is equal to, the elements are A, B, C. These are the elements. So, these are the elements. Okay, so the number of binary operations, we need to find the number of binary operations. Yes, so the number of binary operations. Yes, the number of binary operations. The number of binary operations, that means we know that yes, n of a, number of elements, number of binary operations is n of a. So the number of elements in A raised to number of elements n of A, the all square. The all square. Okay, so for this question, number of elements, look at here. Number of elements is 3. Number of elements is 3. So we can write that is equal to 3. Yes, n of a 3. N of a what up here? N of 3 raised to 3. The all square. 3 raised to 3. The all square. We know that 3 square, that the value is 9. So it will become 3 raised to 9. 3 raised to 9 is the final answer. Yes, again, just go through the options. While we are going through the options, we can see that 3 raised to 9, that is the first, yes. So the first option is the correct answer. 3 raised to 9 is the correct answer for this question. So the next question is given that if A and B are square matrices of same order, and B is a skew symmetric matrix, then we need to find A dash B A. Okay? Yes. So if A and B are square matrices of same order, so we can write A and B. A and B are the square matrix of same order. Same order. It's given that B is a skew symmetric matrix. B is a skew symmetric. Yes. Skew symmetric. B is a skew symmetric. What is skew symmetric? Skew symmetric is nothing. B transpose is equal to minus B. That is skew symmetric. Skew symmetric matrix. Yes, B is skew symmetric, so we can write B transpose, B dash is equal to minus B. So this is a condition for skew symmetric matrix. B dash is equal to minus B. Okay, so they are asking us to find A dash B A. They are asking us to find the value of this one. Okay, so A dash B A. So first of all, I'm going to take A dash B A again, because we know that for a skew symmetric matrix, B transpose is equal to minus B. So look at the options. First of all, look at the options. So the options is given us, first one is skew symmetric matrix, second one is symmetric matrix, third one is null matrix, and fourth one is diagonal matrix. Okay, so first of all, from this, I'm going to take the transpose, that is A transpose B A, the all transpose, A transpose B A, the all transpose. So that is equal to A transpose, the all transpose. What is that? We know that A transpose, the all transpose, that is equal to A. Yes. Isn't it? A transpose, the all transpose, that is equal to A. And here it is B transpose. Yes, B transpose. and the last one is A transpose, B transpose, and the last one is A transpose. Yes, so here B transpose, we can substitute it as B. For B transpose, we can substitute it as B. So we can write it as A minus B A transpose, A minus B A transpose, A minus B A transpose. So that is equal to, finally we can write this is equal to A minus B A transpose. So this is equal to, just take the minus outside, so minus of, yes, A transpose minus of A transpose B A minus of A transpose B A. So what is this? So we can write hence A transpose B A is a skew symmetric matrix, because look at here, minus, isn't it? A transpose B A, the all transpose is equal to minus of this. Yes, A transpose B A, the all transpose is equal to minus of A transpose B A. So we can write hence A transpose B A is a skew symmetric matrix. Skew symmetric. Skew symmetric matrix. Yes. Okay. So for this question, option A is the correct answer for this one. Yes.